things, we're going to recap a bit on what we learned last week. Okay, last lesson. So we learned about if then block, if else block, and we also learned about forever looping. Although it might call different in other languages. In other languages, it will call while loop or for loop, but in Scratch, it's using the term as forever loop. It's the same thing. Okay, the concept and logic is the same. The next thing we learned last lesson is variables, how to create variables. Okay, so in our lessons for now, we don't really focus on how to build complex games. Instead, we want to learn the programming blocks, the foundations well, and then give us a solid foundation before we proceed to build more complex games. So in this lesson, we're going to learn about 5 reporter blocks in Scratch. First one is timer. As you can see, I already on the timer on the stage here. So where's the timer? Under sensing. You might wonder why we need this timer. Okay, so you can check and uncheck this to show whether you want to show the time of the gameplay or not. So some of you might question why we need to learn timer. Okay, timer actually used across so many games. You can use this as a gauge line to let players level up within certain period of time. If the player complete the task, you can allow the player to go to next level. If they progress well, you can give more bonus or something. So all this, maybe we need a time as a guideline to decide whether the player proceed in the game or not. Okay, so let's do a simple block to illustrate the how we use a timer. It won't be a complex complete game, but then it's just a simple block to demonstrate how the timer is used and then what's behavior. Okay, so first let's do a flag. When the flag is clicked, we're going to wait until, which is in the control, wait until, where are you? Okay, here. And we're going to use the operators to check whether a certain time is reached. Now we can drag the timer, the little timer thing over here. Okay, so we're going to check the current time. If it's reached 50, let's wait to 10. Then we're going to give some response to the player. So we will say time's up, and we're going to stop all. Let me edit the text later. Let me find the stop all first. So with this simple block, right, we're going to show how the timer works. Okay, so let's say if I on the flag, you will see the time restart from 0, 5, 6, 7, 8, 9, 10, and then the cat will give you some response, depends on what the code says. If you can observe here, actually once I stop all, but then you might wonder, oh, how come the time never stop? Okay, this is something we need to take note. In Scratch, the timer doesn't really stop on itself, but it can be reset if you click the flag. So something about the real world, but something not true about the real world. Okay, so real world time continues no matter what you do. There's no reset time button. I mean, so far we don't have one. Okay, maybe in future we can invent time machine, then we can control the time, but not for now. But then there's something that not existed in the real world is when you click the flag, it actually able to reset the time back to 0. So this is something unreal, but it's commonly used in the game world, in the virtual world, in other words. Okay, so this is how it behaved. Let's use another character to demonstrate. Another useful block is pick random number. Okay, so let me add say I want to add a skeleton. Where are you? Or maybe I can find it. Skeleton. Okay, so here, if I'm using this sprite, the reason is I don't want to use the case for the cleaner working space, since I just want to demonstrate the reporter block in Scratch. So let's use a new sprite to demonstrate the random number. Okay, so let's do a simple code to generate, to show the skeleton based on random time numbers. Okay, let's see. Okay, first let's find the flag, and we're going to first hide the skeleton when the game starts to play, and then after a certain time we're going to show, right? So just put it around here, and we're going to wait how many seconds. We don't want to give a fixed number because we want to add some randomness into the game, where you creators also don't know when something will happen. Player also don't know, it adds some fun element inside, but we can always control a range. Okay, so how is that work? So we're going to use this as the range. So first is the starting point, let's say pick random from 1 to 10. Okay, let's just leave the number here. Of course you can extend or less the n number, but this is the range 1 to 10. So computer will pick any number between this range, meaning that between 1 to 10, and I'm going to show the skeleton. Okay, so just in case it picked 10 and then stop all the code and our skeleton won't work, so we're going to detach the stop all here first, so we will be sure that this code will run no matter what. Okay, so skeleton is no more, and let's wait. 3 seconds it appears, so let's restart and see how many seconds it will appear. 3 again. Let's try one more time. 2, 3, 4 this time. 5, 6. Okay, so you can actually see that we add some randomness. I am the creator of this, but I'm not sure exactly which time the skeleton will appear. My reaction will be same as the player. It will add some fun element in your game. You might ask, where should I add this functionality in your game? Maybe a good example would be a random enemy showing in your game, where we can fight with, but we can't really control when does it come out. Okay, so this is another example of reporter block in Scratch. So next, let's add another. I will add an apple. So this apple will help us demonstrate X and Y positions. Okay, so this is very important, as in the first lesson you can go back to the first video where we have this backdrop. Let me go back to the backdrop. This. Okay, so XY position controls the character's position, in other words. Okay, so let's say I position the apple here, you will see the X and Y value is changed accordingly. That if I want to place apple here, and you see that 10 becomes 145 and 1 becomes 6. So this is basically how we can control the sprite position in our gameplay. We also, this is a manual way, of course, but we can also use code to control it. Okay, so let's do a simple code to understand more about X and Y position. So go to flag, and let's have because I want to make a continuous movement, so I will use a forever loop, and I will change X. I will change X by 10. So I will continue change the X value, which is this value, by 10, and until a certain condition met. Now we can use our previous lesson knowledge, if then, to decide when it should stop and do some instructions. Okay, so if the X position, let me do our operators, check. X position, which under here. Okay, apologize that my video will be cut off a bit in the middle because I just aware that my video got kind of half. So when we checking X position if larger than 240, which this right coordinates here, the apple should stop and then run out certain code instructions inside the if block. So let's say reached the edge. And let's drag back the apple and run the code. So you will see that the apple around here will say, hey, I reached the edge. But if we want to reduce the manual work of drag the apple back, we can always use code to settle the manual work. That's the purpose of coding, isn't it? To reduce human task. Okay, let's set the position to minus maybe this position, or go to the edge a bit more. Okay, so as you can see, this one is auto updated, and so do this. So you can, if this is a right position you want, you can always get the most updated XY coordinates value and attach to your script. So by this, when we run the code, it actually relocate the apple to the original position and slide through the screen, the stage area, until it reach the other side. Okay, so this is the demonstration of X position and Y position. Now let's add another sprite to show you the difference between another reporter block very similar to this, but it's called mouse X and mouse Y. Let's add a balloon. And in order to illustrate this, we're going to do a simple code, very simple. Say I'm using a flag and I want it to be in a continuous action. And now is the things that we're going to learn is mouse X and mouse Y. Let's observe the mouse X first. So what are we going to do with this? We're going to set the movement of X followed by the value of mouse X. This mouse X is not the animal mouse, okay? It refers to your computer mouse. So basically, you see my mouse is running around the screen, across the screen here. It actually gets the coordinates of this mouse X value and update it into here. So since it's in your forever loop, right, it will keep following my mouse position, left and right only. It will not go up and down because we haven't set the Y axis. So that's the challenge. So the challenge is, how are we going to add on to this code so that the balloon will follow 100%, meaning that it will follow left and right, up and down with my mouse pointer. So go to set Y and just update the set Y value to mouse Y, and now you can see that balloon is following the mouse pointer perfectly. So just to take note, X position and Y position is different from mouse X and mouse Y. This darker blue position values refers to the spread coordinates on the stage, whereas mouse X and Y actually refers to the coordinates of your mouse movement. I hope you can get this idea clear. Now we're going to move on to the last part of the lesson. Okay, so let's do the last part. Let's say, what if I want to change another backdrop? Okay, let's say I want to display this off. Okay, let's focus on the balloon here. Throw away the code. What if I want to you might wonder sometimes in the scratch, say, hey, where's my sprite? You can always do menu setup here. So back to the center. let's say we want to duplicate this balloon 5 times. You can always right click and duplicate, so the code will follow the duplicate version also. At the same time, you are copying the code also to different duplicate version. Let's try, let's say I'm adding this code, and when I try to duplicate, the second one will copy over together with the code. Okay, it's okay if you're going to just make a few duplications by this method, but what if you're going to duplicate 200 balloons in your game? Does it make sense to right click 200 times? Definitely no. Okay, so we're going to automate this process by the cloning script. So let's do the cloning script here. Delete the duplicate version. Let's try to clone just one balloon first, and from there we can enhance the code further. Let's say when the flag is clicked, I'm going to make a clone of myself. Okay, not myself, the balloon. Yeah. Then I'm going to also need, when I start as a clone this block of code, let's change the color by 25, just a random color. I think it's blue, dark blue. Yeah, so let's do this, the simple one. All right, so if I going to say something, let's say I'm the clone. Okay, that's purposely to do it, not the perfect way. Later you will appreciate, you will understand why we need to do enhance the code a bit. Okay, so let's click the flag, and you will see that, hey, I said I'm the clone, but only one balloon is here. Why? Because if you don't move the balloon away, it actually overlay. It overlay behind the original. So we're going to enhance the code a bit, meaning that we're going to move away, move 100 steps away. Okay, so here when we try to play again, we can clearly see that this balloon is move away, the clone is move away from the original, and we can see much more cleaner. Okay, let's delete the skeleton so we can follow focus on the balloon here. Now you might ask, oh, if I'm going to just clone one, then why I need to do the code instead of doing this? So okay, so we are going to clone 200 times. Okay, and then you know that the clone is going to overlay, so we're going to move into random positions, so we can see the cloning going around in the stage. It won't overlay into one position. Okay, so as you can see here, 200 balloons are cloned and still cloning. Okay, roughly done. All right, so now you can see the easiness of a difficult task by a clone script like this. Actually, we can even further enhance this code, meaning that we can make use of what we learned. Let's say just now we have this 25, right? We can randomly change a code, use random colors on each balloon, on each clone, in other words. So minimum, this one is about RGB value, and RGB value we're going to teach in beginner Python. If you want to know more, you can always contact us for course details. We're not going to put many tasks or activities details here because it's very time consuming. Okay, so we're going to use the pick random code block that we learned just now, and change each balloon's color into random color and go to random positions. So 0 and 255 is minimum and maximum value in RGB. This is teach in beginner Python. I won't go into detail here. So let's see the effect. Okay. As you can see, this is the clone and the rest is the this is the original, the rest is the clone with more colors. It will be more interesting, right? Now let's do something more interesting, meaning that if I add a forever loop wrap around the change color effect here, it will actually make the balloon color blink per run. Okay, that means each balloon will keep blinking the colors, keep changing the colors non-stop, let's say. So this is how easy you can use the clone code to actually achieve something that seems difficult. Imagine you're going to right click 200 times and then edit each balloon with this blinking effect. It's very tedious, but with one sprite, with this clone code, we can make it more easy. Yeah. Okay, so this is all about the lesson contents that I want to deliver. If you want to do like more complex games based on what you learned, you can always contact us, and then we will give more details on the activities. Okay, so for furthermore, let's see you next week for more learning knowledge. Thank you.